Alright, start and end points. Let's just talk about all the graphs for a minute. Alright, for sine and for cosine, hopefully by now you know that our start and end points always occur at 0, and my end point always occurs at 2 pi. And what's nice is that since we have our reciprocal functions of cosecant and secant respectively, they have the same start and end points, because as I said in a previous video, to get cosecant we first need to graph sine, and to get secant we first have to graph cosine. So the math doesn't change, just the shape of the graph. Okay, but when we got into tangent and cotangent, we realized that some things were different. We said, well, tangent of theta is a different shape altogether, and we get this really weird graph. In fact, we get this graph, oops, didn't mean to change that page, that looks like this. Okay? And I told you that this happened because tangent is actually the sine graph being divided by the cosine graph. And since wherever cosine is 0, which is on the denominator, that is where we get those vertical asymptotes. And then wherever sine is 0, that's where we get our roots. And we know that the period for this even changed to just pi, when the period for sine and cosecant and secant were 2 pi. Okay, so this is why I have you graph two periods worth, and this is why the graphs look like that. So it turns out that our start and our end point for tangent turned out to be where the vertical asymptotes were. And the vertical asymptote occurs right here and right here. Okay, well, those values turn out to be your start of bx plus c equals negative pi over 2, and your end turns out to be bx plus c equals a positive pi over 2. So the idea behind finding your points doesn't change. Okay, you're still finding your negative pi over your start for your negative pi over 2, and you're still finding your end of pi over 2. But we don't need a second and a fourth point. We only need that middle point. Okay? And I think I have a nice picture for this of what we did in class. We said that in class, I think you guys came up with these steps. And we said that for your start, you find that, and then for your end, you do it that way. And then your middle, you find exactly the same way. Only now you don't need your second and fourth point. Once you find your start, end, and your middle, you're done. Then you just go straight to the graphing. And then you look for a pattern, or some of you said, you know, add the distance from your start to your middle to your end, or whatever it was, okay? Well, let's just go ahead and do an example to show you exactly what I mean by this. So we're going to do tangent of, well, let's just start off a little bit simpler. Let's just do 2x minus pi over 2. Let's not do any shifts. Let's just do basic. Okay, so we're going to start this out the same way. So on here it says do our start, and we set it equal to negative pi over 2. So we have our start, which is 2x minus the pi over 2 equals a negative pi over 2. Yes, I know, I made this easy. Get over it, okay? I'm worried about concept here, not on the math. So we're going to add the pi over 2 because we're trying to solve for the x to figure out where this shift and the shrink in this case is taking it. And when we add it, we get 2x equals 0. And then when we divide by 2, we get x equals 0. So our start point is now 0. And our end point, so we need to take the 2x minus pi over 2 equals a positive pi over 2. So in case you forget, that's what it tells us to do for step 2. It says set it equal to a positive pi over 2. Okay, so I'm going to add pi over 2 to both sides. So I get 2x equals 2 pi over 2. Okay, which of course is just 2x equals pi. And then when I divide by 2 on both sides, I get that x equals a positive pi over 2. Okay, so what we have here is we have my start, which was at, we said 0. And we have my end, which we said was at pi over 2. And the nice thing about this, which I don't think I wrote on here, is that our start and our end point are always going to be our vertical asymptotes. And I mentioned that before, but I didn't write it on the board when I took this picture. So that helps me in this sketch because I know that this right here is going to be a vertical asymptote, and this right here is going to be a vertical asymptote. Okay, well, I still need to find my middle point. So I do that the same way. I go 0 plus pi over 2, which is pi over 2. And then I divide it by 2 or multiply by 1/2, so I get pi over 4. Okay, so my middle point becomes pi over 4. Okay, well, we pretty much have everything, so all I need to do is graph it because my middle will always be my root. And it just has this shape of going up. I just remember the tangent arrow is going up. Cotangent, you go down. Okay. Well, this is where that step 5 comes up. 5 is where you find the pattern or you add the distance. Okay. We know that the distance from here to my middle point is going to be 1/4. And we know that 1/4 plus 1/4 is 1/2. So I should be able to find my second period by just adding 1/4 each time. Or pi over 4 if you want to get technical. But I'm just kind of simplifying it out. Well, pi over 2 plus 1/4, okay, if you need a picture for that, here's 4. So we have pi over 2, which is 1/2, and we're adding another 1/4. Well, that's going to be 3/4. And if I add another 1/4, well, that's going to be a whole, so that's pi. Or some people have figured out that if you find a common denominator, so we're looking at 0, and we have pi over 2, and we have pi over 4, that we can find a common denominator just by changing this to 2 pi over 4. And now look, we have 0, 1/4, 2/4. Well, after 2 comes 3, and after 3 comes 4. And of course, if you reduce 4 pi over 4, you get pi. And that's how we find our second period. Now, what's nice about this is that cotangent is done in exactly the same way. Except for now, the start and the end points have changed. So now, because the cotangent graph shifts, because sine is now the denominator and cosine is now the numerator, so the whole graph kind of changes. So without even worrying about the other graphs on here, I only want to look at the top two. So this right here was tangent, okay? And this right here is cotangent. So notice that besides the shape of the graph, because I know that tangent goes up and cotangent goes down, but notice that wherever I had a vertical asymptote is now a root on the graph. See right here? Okay. And wherever I had a root is now a vertical asymptote. Okay? So everything changes, everything flips over, which makes sense that our start and our end point, because we want those to always be our vertical asymptotes, would change as well. But everything else is exactly the same. You still find your start, your end, then your middle, and then you graph it, and then you look for the pattern to find your next 2 points. Okay? Alright, so overall notes. We have sine, we have cosine, so sine, cosine, secant, and cosecant. The start and end points for those are bx plus c equals 0, and the end point is bx plus c equals 2 pi. For tangent, your start point is going to be bx plus c equals negative pi over 2, and for the end, it's going to be bx plus c equals a positive pi over 2. And then for cotangent, didn't finish that c. is going to be, for your start, bx plus c equals 0, and an endpoint of bx plus c equals pi. So that would be like your cheat sheet. Okay, I would also go ahead and write down the steps for tangent, and this is for tangent. Okay, and I would make sure that I write, oh look, these two, steps 1 and 2 are my vertical asymptotes, and for step 3, that's always going to be my root. Likewise, for cotangent, my steps 1 and 2 are always going to be my vertical asymptotes, and step 3 is always going to be my root, my middle point. Okay? So if you look at the difference between the two, it's just what the start and the end point becomes equal to, what you set them equal to. But the steps don't change. Okay? Alright, I hope this helped you.